So you'll find this in Google Classroom, lesson 6.0. It's just some preliminary stuff from um, chapter 6 that you'll need to know to help you get through that mod 6 from your Algebra 2 course. So if you didn't know this stuff, we'll go through it, and remind you some of the rules. We're going to do the first 2 pages today, and those will be due at the end of class. And then we'll do the second 2 pages tomorrow, and they'll be due at the end of class. I'm going to do the odds with you, and then you'll work on the evens for the rest of class, okay? So in this lesson, we're talking about simplifying rational expressions. Now, it's really about reducing a fraction with common factors. So when we look at problem number 1, we're treating the numerical components like we would a fraction. What is a number that would go into both 36 and 42? Both of those are divisible by 6. So first, let's think about dividing both of those by 6. Now, as far as the x's, you're looking for the lowest power. So our lowest power is x squared. So technically, I can divide out an x squared from both top and bottom. So you're really doing it in 2 kind of pieces. Reduce that numerical component, reduce that the x's. So if I reduce the 36 and the 42 by 6, I'll just keep the negative going out in front. I get 6 over 7. Excuse me. And I'm going to leave a little room in case I have some x's left. The rules of exponents say if the bases are like and we're multiplying, or I'm sorry, dividing, keep the base and subtract the exponents. So 3 minus 2 is where we get 1. But you can see if I divide 2 off there, I have one of those left. And x squared divided by x squared is 1. So you can think about it a mixture of ways. That would be your final answer. There is no way to go further. That is what you do. Okay, so we're just going to keep practicing. So as far as 16 and 28 goes, they are both divisible by 4. So if we divide them both by 4, that will reduce the numerical component. The rules for our p's, think about the fact that we have 2 p's on top, 1 p on the bottom. If we cancel out 1 from each, we would have a p in the top. So it is as simple as 4p over 7. Both top and bottom are divisible by 14. So if you divide the top by 14, you get 5. If you divide the bottom by 14, you get 2. And say you saw 7 instead of 14. You can divide it once and then reduce again. It doesn't matter. It doesn't hurt anything. Okay. We again have the extra ends in the top. We have 1 extra that is in the top. Now, when we get to number 7, when we start to have binomials, more than one term, that plus or minus between them, you have to use your rules of factoring. So you have to be careful, make sure you're factoring correctly. Both top and bottom technically contain an r minus 2, but you don't really see it until you notice that there is a greatest common factor of 2 that I can remove from both of those pieces. You have to remove that first. Don't just start trying to cancel pieces with pieces. You can't do that. It has to be the entire binomial crosses out the entire binomial, so we can cross those out. So our answer is technically 2 over 1, or again, you can just jump to the 2 if you see that, okay? So that reduces down to 2, just because of the way that that greatest common factor comes out. Now, let's look at number 9. Now, the top is not factorable. Put that entire quantity in parentheses. That's going to help you to not make a mistake where some people want to cancel out pieces of the binomial. You think that's connected. They're together. That x minus 4 goes together. 9, both of those pieces have a greatest common factor. What is a numerical component that we can take out of both of those? Yeah, you can take the 3 and you can take the x. So let's do that. Now, just be careful when you do that, that you're taking out the correct thing, that if you were to redistribute, you would get what you see on the paper, and you have an x minus 4. Another common mistake that people make when they go to cancel those out is that they want to not account for the fact that that x minus 4 that was on top, anything divided by itself, leave that 1 there so that you have, don't just think your answer becomes a 3x. It's 1 over 3x. So I like to keep a 1 if in a spot where everything went away. Technically, you had a 1 there. So make sure that you're accounting for that. Let's talk about 11. Again, that top piece is in full factored form. Put it in parentheses. The bottom piece, there's a variety of ways to rewrite the bottom. What we're basically doing is doing one of those. What are the factors of 25 that will add up to 10? They are both negative. Remember the rules, we had talked about them a little bit yesterday, but if this is positive, just look to the center. That's what's going to be in both. And we're adding to get that middle term. So 25 is 5 times 5. 5 times 5 is 25, and it adds up to 10. Now you can write it like that. It's not a bad idea to write both of them. It's optional. You can also write that as v minus 5 squared, since they are perfect matches. It still works like any other quantity when you reduce down the powers. It's up to you. But as you can see, one of them cancels. Again, that's one where we do want to show that 1 in the top. You do want to show that 1 in the top, okay? So that would be our answer to 11. Now, the reason we're doing this is we are going to be exploring in Mod 6 rational functions, what their graphs look like and all those things. And these reduced factors actually give us a specific thing that happens in the graph. So if we can't reduce it right, we're not going to be able to graph it right. So we need to practice this algebra, make sure we understand that. Let's look at number 12. Now, let's focus on the bottom first. Both 27 and 18 are divisible by 9. So let's take out a 9. If you take out a 9 for both pieces, we are left with 3x plus 2. Now, 27 is perfectly divisible by 9. So if you just put a 27 there and reduce it, that's fine. You could break it apart. 27 is 9 times 3. It's not a bad idea to write it like that, because then we specifically see how the 9 cancels out and leaves a 3 behind. But obviously, hopefully, 9 goes into 27 3 times. It would also leave a 3, however you want to think about it. But we would be 3 over 3x plus 2. Now, please, this 3 and this 3 are totally different things. This 3 is dependent upon your x value. It is stuck to the plus 2. Don't try to reduce it. You can't. Leave it alone. Okay, so that would be our final answer. Everybody good with the problems we've seen so far? Do we have any particular questions or concerns so far? Okay, let's keep going. Now, if you see a trinomial on both the top and the bottom, those quadratics, it's essential that you know how to factor them. So when the front number is just a 1x squared, it's actually, pretty nice, because, if the back sign is positive, you're adding to get the middle. Just repeat that symbol in both places. If the back sign is negative, you're subtracting to get that middle thing. So let's first just rewrite things with the correct signs alone, okay? We'll put the numbers in a second, but just look, let's put our signs. I know without looking at what the numbers are that the top has to be x plus, because if the back is positive, just look to the middle, that will repeat twice. If the back is negative, I know one's plus and one's minus. Now, how do I figure out which goes which? Well, if your middle sign is positive, your biggest number in the subtraction pair should go next to the positive. So just the middle number is telling you which one won, which one is the bigger number. Okay, now let's focus on the top. We need a pair of numbers that multiply to give you 12, but add up to 8. Well, 12 is 6 times 2. 6 times 2 is 12. It adds up to 8. That's what we want. Now on the bottom one, we're looking at 18. We're subtracting to get 3. 18 is 6 times 3. That's your 18. We're subtracting to have a difference of 3. We need the bigger number to be positive because we want the 3 to be positive. So put your bigger number next to the positive and your little number next to the negative. If the middle sign was negative, you would put the bigger number next to the negative symbol. Now and only now that we have done that, can we cancel out a perfect binomial match. So that x plus 6 on top and the x plus 6 on the bottom, perfect match. Our final answer is x plus 2 over x minus 3. At that final stage, feel free to put the parentheses or not, but just don't try to cancel out the x's. There's a silly poster I've seen in some algebra classes, and it has a kitten like hanging from a limb, and it says every time you cross out the x's like that, a kitten dies. So I don't know if that's going to help you. Kind of morbid, but don't do that. A kitten dies when you do that. Don't do that. Anyway, there's 15. Let's talk about 17. We still got that b squared in front. That means it's a nice quadratic. That's probably going to factor. The top one, we want the factors of 28 that have a difference of 3. 28 is 4 times 7. That's where your difference of 3 is going to come from. We need a plus and minus because our back sign is negative. When the back sign is negative, that's the only way to get a negative 28. Now, we want the bigger one to win, so set your bigger number next to the positive and your little number next to the negative. And you can FOIL that back out and see, do I get what I started with? The check of any factorization is a multiplication. So if you're unsure, remultiply it in your head or remultiply it on paper. Did I get what I started with? If not, you didn't factor right. Now, 17 is a difference of squares. Let me remind you of that formula. We've talked about this formula again and again. Remember how I said if the back term is negative, you got one positive, one negative. Look what happened. We got one positive, one negative. And it's just the square root of whatever's sitting there. The square root of a squared is a. The square root of b squared is b. So just square root those things. So we get b plus 7 and b minus 7. So make sure you know that formula. That's one that's going to come up again and again. You got to know that. You got to know how to factor. It's essential as we finish mod 6. Okay. Now I know you guys haven't particularly enjoyed iMath. I haven't either. But you know, all these things I would have taught you one way or the other. I would have just maybe approached it a little bit different. But this is what pre-calc is. You know, it just is kind of its own ugly little beast. I will tell you, if you guys ever take calculus in your future, it is nicer. I like it more. It's actually more algebraic. You would like it probably better. I found even myself, I like algebra 2, then pre-calc's kind of, and then calculus comes back again. So if you ever take in your future, you might like it. Okay, so now we found this b plus 7's canceled, perfect. So we have a b minus 4 over a b minus 7. Okay, so that is problem 17. Let's talk about 19. Now this is one where we just have some greatest common factors living in there. Both of the pieces in the top, and you always check for that greatest common factor before you do anything else. Both of the pieces in the top are divisible by 4. Don't forget that you will have to have a 1 there. And again, you can check any factorization by just remultiplying. Will I get what I started with? If you didn't do right. Both the pieces in the bottom are divisible by 2. So we get 3n minus 10. And we're going to check two things for our final answer. The n minus 1 and the 3 and minus 10 are not common factors. They have to be perfect matches. They're not. There's nothing we can do. We're going to leave those. So I know my answer is going to contain an n minus 1 and a 3n minus 10. It is what it is. Okay. Excuse me. But the 2 in the bottom and the 4 in the top, they can reduce, right? 4 is divisible by 2, reduce it. And that would leave us with a 2 in the top. If you put a little 1 here, because they're both divisible by 2, I divided by 2, it doesn't hurt anything. Normally we don't include the 1 factors, but you can. It doesn't hurt anything. Everybody good with 19? Let's look at 21. Now this one requires kind of multi-steps as we go through the process, okay? I kind of always think of, when I'm factoring, let me kind of give you a little rundown of what I do. The first thing I look for, is there a greatest common factor? Take it out if there is. Second thing you want to look for is, what is the pattern? Is it 3 terms so that I can unfoil? Is it 2 terms that it has a pattern? It has, like, is it a squared minus b squared? There's a few others. If we get to them, I'll show you. Is it 4 terms? Which isn't going to happen too often, but occasionally does. That's a grouping one. And then always check again. Did you forget anything? So anytime I factor, I taught Algebra 2 for 1,000 years, 5 periods a day, probably for at least 15 years of my life. That's why I always taught factoring. And it's really just a good method. Is there a greatest common factor? Take it out. Is there a pattern I can see? What can I do? Once I've seen that pattern, check my work. Did I forget something? Because sometimes you'll see, like, oh, there's a 2 in there. Let's take a 2 out. And then you'll do it again. And, oh, there's a 3 too. Take it out again. It's nothing wrong with if you do it in a few steps more than I did. Who cares? Okay. Now, that being said, if we follow my little pattern for the first one there, the top, everything is divisible by 6, and there's 2v squareds. The lowest power you can always take out. So let's do that. Let's take out 6v squared. So I'm left with a v plus 7. Now again, you can check a factorization. If I remultiply, do I get what was originally on the page? Which I do. It's great. That's wonderful. The bottom one, there isn't a variable in every single one, so I can't take out a variable. But they are all divisible by 2. So let's take that 2 out. Let's make our lives a little easier. It's usually easier to factor a quadratic if there isn't a front number. And so if I can take out that 2, that's great. And I'm left with v squared plus 13v plus 42. Okay. Now remember, my little hints, my little steps over there say that take out a greatest common factor and then look at the pattern. The top v plus 7 is done. There's nothing I can do about that. But the bottom is a factorable quantity. The factors of 42 that add up to 13 are 6 and 7. So I'm going to make that v plus 6 and v plus 7. And then let's just take a look at what factors we have in common that can cancel out. Okay. So if we look at some common factors, we got that v plus 7. That's a perfect match. We can take that out. 6 and 2. 6 is divisible perfectly by 2, or you can think they're both divisible by 2, or however you want to do it. That would leave a 3 in the top. So our final answer in the top is where the 3 lives and the v squared lives. And then the v plus 6 lives in our denominator. Excuse me. Everybody good with all the steps that we did there? And then always check your final answer. Check again. Is there anything else I can do? There's nothing left I can do. Because sometimes in one step you might see something that you didn't notice in the next step. So then you find something in the next step. Okay. So my hint to you again, take out any greatest common factor. What's the pattern that's left? Can I do something about it? And then check again, is there something I miss? Reduce as much as possible. Okay, okay. So that's 21. How many more we got in the odd column here? 2 more to go, okay? Okay. So now, yeah. So for the numerical components, they always act like just normal old fractions. So just do that like a normal fraction. So 6 divided by 2 is just a 3. Don't worry about, just be careful. If it was 2 over 6, make sure to put the 3 in the denominator. If it's 6 over 2, put the 3 in the numerator. So don't overthink the numerical parts. Just treat them like normal fractions or numbers. Do what you got to do to those. And then the algebraic parts kind of have to be some perfect matches for things to cancel out. No, because it only affects it if we're like trying to add or subtract like terms. But if we're multiplying or dividing, it just kind of might stay along for the ride. So yes, that b squared just kind of stayed there because there was nothing to change it or cancel it. Anyone, any other questions about 21? Okay, let's do 23. So again, if we follow our little steps, the first thing we need to look for are greatest common factors. What is everything on top divisible by? 2. Let's take out that 2. What is everything divisible by on the bottom? You find the biggest number that we can go into both 8 and 64. Yeah, why not use 8? Now, again, if you did not see that it was 8 initially, if you saw 2 and then saw, you would find it eventually, but you want to find that biggest number if you can right off the bat. That's the most helpful. Next, let's find the factors of 24. Do we have some that make a difference of 5? 24 is 8 times 3. 8 times 3 will give us 24. It will have a difference of 5. Why difference? Well, when that back sign is negative, one's plus and one's minus, no matter what, we just want the bigger number to sit by the positive. So we get a positive 5. So we want the bigger number by the positive, a little number by the negative. Someone made this up so that things would reduce. So if your bottom has a b plus 8 in there, does 8 go into that back number? Is it a way to get an 8 to show up? So use the clues that are there. Sometimes that will kind of guide you. And so now a few things can reduce the 8s. Now here's where the 2 goes into our bottom number. So our when we reduce it, that 4 has to live in our denominator. So be careful, excuse me, with stuff like that. So on top, we are left with a v minus 3. On the bottom, the only thing left, we kind of canceled everything out, but a 4. Now, I've seen it rewritten like that, but I wanted to also show you another way that you could write that. That is also equivalent to 1/4 times v minus 3. I'm okay with you just stopping there. There's some things, if you're in a calculus class, or even if we're looking for zeros and things, where removing that numerical 1/4 isn't a bad idea. But stop here if you want. Rewrite it like that if you want. Doesn't matter to me. There is 23. Do we have any questions about 23? Okie dokie. Last one, and then you're going to be working on this for the rest of class. It's due at the end of class, okay? I notice in the top part that there's no greatest common factor, but we can take out a 2x. And I'm going to kind of do it right here just so that then I have a little more room on the next part of things. So if I take out a 2x from every single piece on the bottom, I'm left with x squared minus 12x plus 32. Okay. Okay. So what I'm hoping is that the top's going to be a factorable quantity, and at the bottom will too, so that hopefully something will cancel out. Now, I know at the top that's an x plus and minus. I know at the bottom that's a minus and a minus. So let's go over those rules one more time. If the back sign is negative, we know automatically it's a plus and a minus, and the middle sign is telling you where to set your bigger number. If the back sign is positive, just look to the center. That sign will repeat in both, and then we're adding up those numbers to get 12 in this case. So if we look at 80, 80 is 8 times 10. That's the numbers we want to get that 2 in the center. Put your bigger number by the positive, your little number by the negative. That will give us that positive 2 in the center. 32 is 8 times 4. 8 times 4 is 32. 8 plus 4 is the 12 we're looking for because we're adding up. If the back is positive, we're always adding up to the center. So that's 8 and 4. They're both negative because that will give us that positive 32 on the back end, but a negative in the middle. Okay. And now we can start canceling things out. The only perfect matches is our quantity of x minus 8. We can't do anything else. Don't try to do anything with this. Every time you do that, a kitten dies. Don't kill any kittens. On top, we are left with an x plus 10. On the bottom, just leave that 2x next to it. Sometimes I'll just leave everything in parentheses, so then I don't try to cancel out something that I shouldn't, okay? Do we have any particular questions about this reducing stuff? Okay, so your job for the remainder of class is to finish out all the evens. When you're done, turn it in. Now, I know your third and fourth pages won't be done. Don't care. I'll only look at the first two for this one. Tomorrow, we'll address the third and fourth pages. Okay, so there you go. Do your thing. If you need me, just ask.